Hello everyone. So today we're going to discuss a problem called 1,000 poisonous wine bottles, something like that. I'm not very sure about the name. So uh, the problem says that we have 1,000 bottles, right? So one, two, three, like this. You have 1,000 bottles, and one of them is poisonous, right? One of those bottles is poisonous. So we definitely don't know which one is, right? So now you have rats. You have rats with the help of whom you can just conduct an experiment and you can figure out that which among these 1,000 bottles is poisonous, right? So your question is that what is the minimum number of rats that you would need for that experiment, right? Okay, so 1,000 is quite a big number, so maybe we won't be able to think of a very nice approach very quickly. So let me just like see the solution is a very basic one, but let us just try few basic things. Like let's say I had one bottle and that single one was poisonous. So I would need how many rats? Zero, right? Because I know at least one is poisonous and I have one bottle. So that means definitely that one is poisonous. Let's say I had two bottles. So how many would I need? So one bottle, another bottle, and one of these is poisonous. So I can just use one rat, okay, some R1, and I'll feed him a bottle, and the other one I'll leave, right? If this rat dies, so that means definitely this is that poisonous bottle, and if it does not die, that means the other one is poisonous. So for one I need zero rats, for two I need one rat, right? Okay. So now let's think about three bottles, right? That let's say if I had three bottles, how many would I require? So, someone who would see this, would hear this problem for the first time, would say I would take a rat R1, I would take a rat R2, and this bottle would be just left like this. So if R1 dies, that means the first bottle is poisonous. If R2 dies, then the second one, and if none of them die, that means the third one, right? Okay. Now let's think carefully about four bottles. Okay. So let's say I include one more bottle. So now, what is going to be the nice solution? The nice solution is going to be, okay, let's feed R1, R2, R3 and leave this, right? So if R1 dies, it's the first bottle. If R2 dies, it's the second bottle. If R3 dies, it's the third bottle. And if nobody dies, it's the fourth bottle. But no, this is not an efficient solution because this uses more number of rats than what we would require in the most efficient way. See, I'll just come up with a more interesting solution. So, see what I could do. I could feed R1 this first bottle. I could feed R2 the second bottle. And what I could do with this particular bottle is that I could feed both my rat R1 and R2 this bottle. So now the solution goes somewhat like this, that if R1 dies, that means it's this bottle. If R2 dies, that means it's the second bottle. Now there's also a case that if R1 and R2 both die, right? Because they have both drank this wine from this bottle. That's the third bottle. So that means if both die, so it is in the third bottle. And if none of them die, that means uh, it's the fourth bottle, right? So now I'll just write it this way. See, as I'm using nothing here, right? For this particular bottle, I'm not using any rat to feed it. So let me write it as 5 or let me write it as 0, right? Let me write for the first one, let me write R1. For this one, let me write R2. And for this one, let me write R1 comma R2. Now after looking at this, could anybody say what is this? Instead of 0, as I'm not feeding it with anything, so it's like null. So let me write 5. So now can someone tell me what is this? It's nothing but the power set. It's nothing but the power set of the set R1 comma R2. So now let me ask you another simple question, that let's say if I had 8 bottles, then how many would I require? Just think it this way. Let's say I had 8 bottles. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah, I have 8. So solution here would be, let me feed R1 this, R2 this, R3 this. Now for this, let me feed both R1 and R2. For this, R2 and R3. For this, R1 and R3. For this, all of them, R1, R2, R3. And for this, none. So now can you see that for all the bottles I have a distinct combination of rats to pick from. There's no similarity. You can look at all of these combinations and all of them are distinct. So now you know that if a set has n elements, has n distinct elements. Okay, I'm talking about sets, so it definitely has distinct elements, but whatever. So if it has n distinct elements, then the number of subsets it could have is equal to 2 power n, and that is what the power set contains, right? So now can you understand that I'll always have 2 power n distinct combinations. So the point is that if I use 3 rats, from then I would be able to create 2 power n distinct, that is 2 cube, that is basically 8 distinct combinations. So basically 3 rats could work even for 8 bottles. Let's say if I had 9 bottles, 3 would not work because that's lesser. So here I would need 4 bottles, but this 4 bottles could also work for 10, 12, 11, 12 till 16 because 2 power 4 is 16, but it won't work for 17, right? So that means for 2 power 9, if you take, so 512, so if there were 512 bottles, 9 rats would do the job, but how many do we have? We have 1000 bottles. So then the power after this is 2 power 10, which is 1024. So that means for 1024 bottles there are 10 rats required. I have only 1000, which is lesser, so definitely 10 rats would be able to do that. So my answer is going to be 10, right? Thank you. I hope you understood. If there are any doubts, you could just put them in the comments.